Okay, so today we're going to be working questions 7 through 14, okay? 7 through 14. We're looking at what is called inductive reasoning. Inductive reasoning is basically patterns, what has happened. 2 days ago it didn't rain here in Bakersfield. Yesterday it didn't rain. Today it did not rain. So by inductive reasoning, I'm going to assume tomorrow it's not going to rain, right? Could I be wrong? Of course. Of course I could be wrong, but I'm just saying inductive is patterns. I'm going to assume things repeat. So let's take a look here. Question number 7. Find the term name in the problem. So I'm giving you guys a list of numbers, right? List of 4. But I want you to find the 40th numbered on the list. Whoa, okay. Now we can do this the long way, the hard way. The hard way is basically, I'm going to see the pattern to begin with. From 13 to negative 17, I'm going to see, well, probably I subtracted, right? 13 minus 20 will give me negative 17. Oh, actually minus 30. Then if I subtract 30 again, I get negative 47. I subtracted 30 again. So first thing, I see my pattern. And like I said, we can do this the long way. From negative 77, subtract 30 again to get the next number, and then subtract 30 again. Keep on doing it until you write 40 numbers, and that will give you the answer. Again, that's the long way. Another way I could have seen it, I can see this, is like, wait, let me start at number 13, right? That's the first number on the list. And I'm gonna subtract 30 so many times. So let me put 30 parentheses. All right, keep in mind, I start subtracting on the second number. So I'm gonna subtract 30 39 times. Right, it's always one less. So I want the 40th number, because I start subtracting from the second number, I'm gonna subtract it 39 times. Okay, I think that would be much easier. I know I have to multiply before I subtract, so I have to do 30 times 39. So I have 13 minus 1,170. That's gonna give me negative 1,158. So I saw a pattern. I'm assuming it keeps on repeating. And then I had to find the 40th number. Now let's take a look at number 18. I'm in number 8. Now here, from 18 to 38, here I added 20. And it seems like I added 20 again, and I added 20 again. It keeps on adding. So I'm going to assume the numbers repeat, right? That's inductive. I'm assuming things repeat. So the way I'm going to find this out, again, you can add 20 to find the next number and do all the way till you find the 25th number on the list. That's the long way. Or I'm just going to say it. I started with 18. That was my first number. And I'm going to add 20 so many times. Since I want to find the 25th number, I'm going to add 20 only 24 times. Again, I start adding starting from the second number. Now 24 times 20 is 480, right? So I have 18 plus 480. That gives me 498. So the 25th number is 498. So inductive is pretty simple, right? I'm going to assume things continue the same way. I mentioned about rain. Let's take a look at question number 9. Inductive might change a little. It's because we don't always add. Because let's take a look. From 1 to negative 3, I will subtract 4, right? 1 minus 4 gives me negative 3. But negative 3 minus 4 does not give me 9. So in this case, adding did not help. Another operation that we know, it's multiplying. I'm more like, all right, can I multiply this by a negative 3, right? 1 times a negative 3 is negative 3. Times a negative 3, yeah, that gives me 9. times a -3 times a -3. So in this case, I'm not adding, I'm multiplying. I can ask you guys, I'm asking for the 11th number in the list. I gave you 4 numbers, right? You can find the 5th, the 6th, the 7th, the 8th, all the way to 11. You always multiply by -3 in this case to get the next number. Or I'm just gonna say, okay, I'm gonna start with 1. That's my first number. And I'm gonna multiply -3 so many times. But now in this case, I'm gonna have to multiply -3 10 times, right? Because it's 1 less. Now do me a favor. Don't put the 10 here. Don't. -3 times 10, that's basically adding -3. Multiplication. When multiplication is repeated, we're not gonna put the 10 there. We're actually gonna put it as an exponent. We learned that when repeated multiplication, we use that as an exponent. So I'm gonna have to do -3 to the 10th. Okay, so let's see. -3 to the 10th is 59,049. So here I have 1 times 59,049. Some of you might be like, whoa, that's a big number. Oh, well, we're multiplying. Yeah, we expect multiplication to make things bigger. Now to finish this, let me multiply that out. And my answer will be 59,049. Take a look at question number 10. Again, I'm stopping at 14th. Here, first I check, am I adding 3 plus 3? But 6 plus 3 is not 12. Okay, so I'm not adding. This case, I'm gonna multiply it. But it seems like now I'm multiplying by 2, right? So the way I'm gonna find the 10th number on the list, I'm gonna say my first number was a 3. So I'm always gonna start with the first number. In this case, I'm gonna multiply 2 9 times. Okay, so I have to find out what's 2 to the 9th. I'm gonna use a calculator. Actually, the way I do this, I go 2 to the 9th. There's a button. You guys should be able to find that. 2 to the 9th is 512. So I have 3 times 512. Remember, order operations, we do exponent first. All right, my answer here should be 1,536. Now let's make this a little more challenging. I'm gonna give you 2 random numbers on the list. I'm gonna give you the 13th number on my list and my 38th number on the list. And I want you to find the 25th number on the list. Now, in order for you to know if I was adding or subtracting, I'm gonna call it arithmetic, okay? Arithmetic means I was adding or subtracting. In order for you to know if I was multiplying or dividing, I'm gonna call that geometric. So 11 and 12, it says given 2 terms in an arithmetic sequence. So I was adding and subtracting. First of all, I need to know how much was I adding each time. So I'm gonna say my lowest number is the 13th number, right? So 91 plus, I'm gonna call this D for the difference. I don't know how much was I adding, but from the 13th number to get the 38th number, didn't I have to add that 25 times? Right, if I had the 13th numbered and I wanted to get the 38th numbered, I will add the difference 25 times. And this was equal to 341. I'm gonna find out what's the difference first, right? What's the number I keep on adding? This plus 91, this positive 91, let me move it as a negative 91. So I have D times 25. Some people call it 25D, it's the same thing. 341 minus 91 is equal to 250. Let me divide both sides by 25. So I get D is equal to 10. Okay, so now I just told you we added 10 each time. But my answer here is not 10. Question here that I'm asking is, give me the 25th number. Okay, the way I'm going to do this, I'm going to choose a number before the one I'm looking for. I want the 25th numbered. I have the 13th. So that's what I'm going to start with. 91. And I'm going to add the difference. In this case, 10. I'm going to add the difference 12 times. Because from 13 to 25 is 12 times. So I have 91 plus 120. Let's see. 91 plus 120 is 211. That's it. Cool. Let's do another one. I have the 11th number on the list. I have the 39th number on the list. So with negative 93 plus the difference, let's see, from 11 to 39, isn't that 28 times? Is equal to negative 373. All right, this minus 93, let me go as plus 93. So I have D, right? D again is my difference. Now, negative 373, let's see, negative 373 and a positive 93 give me negative 280. Let me divide both sides by 28. So my D is negative 10. This time I keep on subtracting 10. All right, now I'm going to use this to find the 27th number on my list. But I'm going to start from the 11th number on the list. So negative 93. I have to subtract 10, right? Because that's my difference. Subtract 10 16 times. Because from 11 to 27 is 16 times. So I have the negative 93 minus 160. Because they have the same sign, I have to add. And I get negative 253. Now let's take a look at geometric, right? What if I multiply? Given two terms in a geometric sequence, find the term name in the problem. Okay, I have the third numbered on the list, and I have the second numbered on the list. I start from the second number because second comes before third. So I'm going to say 9 times, I'm going to call this ratio, the R, the number multiplied. I don't know what's the number multiplied. I'm going to call it R. From the second number to the third number, isn't that just one time? So 9 times R one time is going to give me negative 27. All right, let me divide by 9. So I have R to the 1 is equal to negative 3. Isn't that R is equal to negative 3? All right, R to the 1. Okay, now I need to find the 10th number on the list. It doesn't matter if you start from the second number or from the third number. I'm going to start from the third number. Negative 27. And I had to multiply negative 3 7 times this case. Right, from the third number to the 10th number, isn't that 7 times? So negative 3 to the 7th. Let me see. Negative 3 to the 7th is a negative 2,187. So I have negative 27 times a negative 2,187. And that gives me positive 59 39,049. Let's take a look at another example. I'm giving you the second number and the fifth number on the list. So I'm gonna start from the second number, right? So 6 multiplied by r 3 times is equal to 162. Because from the second to the fifth, isn't that 3 times? All right, 162. Let me divide both sides by 6. So I have r to the third is equal to 27. All right, what number multiplied by itself 3 times gives us 27? 3. Right, 3 times 3 times 3. Okay, I need to find the 10th number on my list. So I'm gonna start, I have the fifth number and I want the 10th number. So 162 times, the ratio is 3. So 3, 5 times. So let me see, 3 to the fifth is 243 times 162 is 39,366. Okay, that's what we did today.